So I'm looking at section 6B, part 1. Two measures of variation that we're going to look at here in this section is range and quartiles. And essentially what these two measures of variation will allow us to see is how consistent our data is to one another. Are all the data points really close to one another and very consistent, or is there a much larger spread of my data and they're much further apart, less consistent? Quartiles will be more telling than range will. You'll see from the formula for range, as you can see on your formula sheet, range is just the highest data value minus the lowest data value. So all that it really just tells you is, the spread from your lowest data point to your highest data point. Doesn't tell you quite as much as quartiles will. So we're going to spend the bulk of our time focusing on quartiles. If we move on down, quartiles, because in the previous section we talked about median, this is a real nice extension of that, because essentially whenever you're finding your quartiles, you're finding nothing other than just the median. You'll always find quartile 2 first because it's the median of the entire data set. And then you will find quartile 1 and quartile 3, and those are the medians of the data that is above and below that particular median. And that's why in the previous section I encourage you to either circle your median or insert your median so that you knew exactly where that number was, and then when you were finding, now whenever we extend it and we find our lower and upper quartiles, we'll know exactly which data points to include and what not to include. Quartiles are dividing your data into 4 equal parts, and I'm going to just draw you a picture here. You will find quartile 2 first, which is the same as the median. I'll just put a little M down there. And then you'll have quartile 1 and quartile 3. Well, quartiles, if you think about it, are dividing them up into 25% increments. So all the data below quartile 1, there's 25%. 25% of your data is between quartile 1 and the median. 25% is between quartile 2 and quartile 3. And then 25% is above quartile 3. And then obviously then totaling up to the full 100%. It should be noted that the middle 50%, so in middle, here starting in the middle at your median, 50% then lies between quartile 1 and quartile 3, because I've got 25% below the median and 25% above. So 50% then is between Q1 and Q3. I just go through down below that, just talking about how to find your medians again. I'm just going to jump right into it because we've spent enough time in the last section talking about medians. You will have what's called a 5-number summary whenever you are finding your quartiles, and you'll have your lowest value, the lowest data value, your quartiles, Q1, the median, and Q3, and then the highest data value. And I'll put that in order for us in just a moment. It should be noted you're finding median, so remember all of your data has to be put in order. So I looked at our data that we had looked at before, the number of surgeries that male Swiss doctors performed at a particular hospital in a given year. And as you can see, I went ahead and put that data in order for you. A little quick recap from what we were doing in 6A. Remember the median. Always find that first, which is your Q2, which is your median. Always find that first. Remember the location of your median is the number of data points that you have. In this case, 15. Add 1 and divide by 2. So that gives me 16 divided by 2, which gives me 8. So that tells me take the 8th entry in my list. So if I'm counting over, the 8th number in my list is 34. I'm going to box that in. So my median then is 34. And remember, like I was saying in the last section, a nice way to check yourself is make sure that you then have the same number of data points to the left as well as to the right, or above and below. So in this case, I have 1, 2, 3, 4, 5, 6, 7 data points below it, as well as 7 data points above it. So I know that I'm straight so far. Then if I need to go and find Q1, and I'll need to also find Q3. I just usually find them in order. Q1 now is the median of these 7 data points. So you can go through and actually, okay, well, I want to find the median now. There's 7 data points, so 7 plus 1 divided by 2. Oh, that's 8 divided by 2. So I'm taking the 4th number in my list. Oh, that'd be 27. So Q1 then is 27. And you can then see, okay, I've got 3 numbers here, 3 numbers between here. Q3 then is the median of these 7 numbers, and of course that's still going to be the 4th entry, so I come over here, 1, 2, 3, 4, 50. You don't have to show this work over here for median, I'm just showing you just a quick little recap. And now what you should be able to see then is that I have 3 data points between each of my quartiles. Okay, and that's, you always want to stay balanced like that. So the 5-number summary would be this. The lowest data point is 20. Q1 is 27. The median is 34. Q3 is 50. And then the highest is 86. Okay. There's not too terribly much different from example 2, but I will run through it. Just to, like I said, just another quick little recap for defining these medians. So in example 2, this is female Swiss doctors who have performed surgeries at a particular hospital and the number that they had performed. So the first thing I want to find then is the median of the entire data set. If you count it up, you would find that there are 10 female doctors represented here. So I do 10 plus 1 divided by 2. That's, always the number of data points, add 1, divide by 2. That gives you 11 divided by 2. That gives you 5.5. So then we know that our median is between the 5th and 6th numbers in my list. So between 18 and 19 here. So I do 18 plus 19 divided by 2. And that gives me 18.5. So there's my median. This would be a case that we talked about before where you want to insert it. Put that 18.5 in there, and now you can see I have 5 numbers below and 5 numbers above. I'm going to go through the Q1 and Q3 a little quicker here. Q1, since I've got those 5 numbers, then I can easily see then that 10 is the median there, and on the other side, Q3, that would be 29. And I'll just point out again, we can see that between each of my pieces now I have 2 data points between each of those quartiles. And then my 5-number summary would be, I'll just add the low then would be, get a better color here, the low would be 5, and I would add in my high would be 33. Okay. I will flip it on over to the next page. This is where you pick up your formula for range, and like I mentioned at the top, range is just the highest data value minus the lowest data value. And like I said before, it doesn't tell us nearly as much as you're going to find in just a moment that your quartiles actually tell you. For example, if I look down here at example 3 and I wanted to find the range, in example 3, this is the number of times that a student in a stat class used the computer lab. So I'm saying one student used it 9 times, another student used it once, another 11 times, and so on. So if I wanted to find the range of this data, then that would be the highest data value, which would be 12 times to the computer lab, minus the lowest data value, which would be 1 visit to the computer lab. 11 then would be 11 visits then would be my range for this data point. Just basically saying that there's a spread there. Okay. What I would recommend that you do at this point is pause the video, go through example 3 and example 4. They're mimicking what I just did on that front page so that you can get a good feel for finding all those quartiles. Okay, and then like I said, I've got the solutions posted for you online in Blackboard. So now I'm going to move on down here to the box plot, and this is where I think you'll be able to see, why are these quartiles telling me more than, let's say, the range does. I want to plot the data from example 3, which was from above. And that's the one we didn't do together, but you should have done that one already. It was the number of computer lab visits, and so we could see that we're going from 1 to 12 visits. So I'll just say, okay, 0, 1 through 13, I believe I can fit on here. You sometimes may not, like a normal, scale down there. Sometimes you might have to count by tens, or hundreds, whatever works, just to make sure you can get the whole plot on one graph. You always label it like you would a typical graph. So these numbers down here on the x-axis, they represent the number of times that the computer lab has been used. The box is always formed by your three quartiles, your quartile 1, your median, and your quartile 3. So you would have found then that quartile 1 was 3 visits to the computer lab. The median was 5.5, and then Q3 was 9 visits. And then form a box with those 3 data points. And then I'm also going to go up here and label that's Q1, the median, and Q3. And then you have whiskers that go out to your highest and lowest data points. So my lowest data point was 1 visit to the computer lab, and highest data point was 12, so then that would be going out to 12 visits to the computer lab. Okay, and I'll mark that with L and H being low and high. And then if you remember, like we talked about on the previous page, that there's 25% of your data between each of these. So I can say, okay, I've got 25% between each of these. And remember, think about all of these are percentages. So now, you probably would have seen, typically where I've seen these graphs like this, your book calls it a box plot. I've always referred to it as a box and whisker plot. Where I've seen these most often is standardized test scores, whether it was maybe your own personal ones that you've gotten back before, or your maybe some that you've seen from your child. When they take a large test that tons of people have taken, they'll sort of show you where your child falls in relation to everybody that took the test. So for example here, where's the middle 50% of your data located? Okay, so remember the middle is right here at your median, 50%, so I'm going to go 25% below and 25% above. That's going to be somewhere then between 3 and 9 visits. So that's how I would word that, between 3 and 9 visits to the computer lab. Then it asks me the question, okay, what percent of the data is above 9 visits? So here's your 9. Above that, 25%. Essentially, it's just all about, knowing what the definitions of these quartiles mean, and that a quartile is always dividing you up into 25% increments. What percent of the data is above 3 visits? Okay, so here's your 3 visits. That's at quartile 1, so 75% then is above me. 25% is below you. Okay. The next piece that we're going to talk about, flipping over to the next page, talks about your data being skewed one direction or another, as well as being symmetric. Symmetric would be even on both sides. Skewed is whenever you have a tail, and that would be one of your whiskers out here, that trails off on one side more than it does on another. I would generally refer to this data, this box plot that you see here, as being very symmetric. It's not perfectly symmetric, but it's, as far as my whisker over here is 2 units, my whisker over here is 3 units. Where I would start to say that I am no longer symmetric and becoming more skewed, I got 2 sitting over here, and then I've got 5 sitting over here. That's whenever I'd say, okay, I'm skewed to the right. So if we flip it over to the next page, this is just this 5-number summary for snake length in inches. And so you can see the lowest data point, 0.5, on up to the highest data point would be 15 inches. So I'm going to take a moment and plot this out. So 0, 1, 2, and again, I'm going to label this. This is snake length in inches. I will then plot my data here. So the smallest then is 0.5. Q1, I usually like to do that first. Q1 is 7, so that I can do my box. Q1 is 7. The median is 11, and Q3 is 14. Go ahead and make your box there. and label that Q1, median, Q3, and then highest data point is out here at 15. I'd already done the lowest data point out here at 0.5. Hopefully then you can easily tell that this data is not symmetric. Out here, this whisker, there's one unit. Down here between this is what, 6.5 units. So definitely skewed here. I would say it's always skewed in the direction of where that long tail is, like we talked about previously. The long tail is over here on the left. So I would say that this data set here is left skewed. If you had a longer tail on the right, obviously right skewed, and then the previous example showed you something that was symmetric. Okay. The next example down below about big bank versus best bank, good examples of data sets that are still symmetric. You know, there's still 25% of your data here. It's just a larger spread of that 25%. Okay. And there's still 25% between here and here. It's just a smaller spread. Okay. The data's tighter up there in that upper 25%. Probably the last thing I need to show you in this section is that sometimes you'll notice that, for example, in example 5, you've got your low, your Q1, your median, and you notice here that Q3 and your height is the same. It just means then, you know, that those will be denoted with 2 labels on your graph. So if I were coming down here and I was going to make my plot, I would start at, I can go 0 to 9. And I'll label this years, and then I will just come up and here's my low value. I like to do the quartiles first and make my box first. So Q1 is 4, median is 5, Q3 is 8, and then if the high value is also the same here, I'm just going to put that. And in this way, then once I do my low data point, which is 2, I'm only going to have a whisker on one side. I won't have a whisker on that other end because the high and the Q3 are the same. Okay, so that's really the only thing different that you would need to see there, and then I'll let you read through the back page just to sort of puts a nice summary on, you know, again, what these quartiles are telling you as far as the consistency of your data, which will be a nice lead in to our next topic of standard deviation.